starting right away, we discuss the basic elements of any computer we see nowadays. We have four main elements: the CPU or central processing unit, the memory, the I/O or input-output modules, and the fourth one is not as obvious. It is the system bus. We won't talk about it here, but just please don't think of it as a bunch of wires going from one place to another. It is more complex. Only a small hint regarding this architecture, which has one memory for both code and data. It is called von Neumann architecture, and it's different from the one in microcontrollers. So more on that in a minute. Now let's discuss those elements in brief. First is the CPU. The most important components in a CPU are registers and the execution unit. Here we introduce very important three pair of registers. Each pair is an address and a buffer. First pair here deals with code memory. Second pair deals with memory. You will find that memory address register and memory buffer register. And here's this one is the program counter. It's an address, but it's for the program code, so this is why it's called program counter. And here you have the last pair, which is the I/O address register and I/O buffer register. So basically how this pairs work is that the address register right here will point to a location, and then the data will be transferred between the buffer and this location. So say you wanna write some data in some location in the memory, you will put the address of this location in the address register. Then the address register will be pointing to the desired location, and then you will put the data you want in the buffer, and then you will command the data to be transferred from the buffer to the memory. And of course you can command the data to be transferred from the memory to the buffer. Okay, you can do both, and this can be memory and it can also be an I/O module. I'm just giving you the concept of this address buffer and how they work. Now main memory is just RAM, and we all know what RAM is. The only note here is that having code and data on the same memory is something that the microcontrollers folks will find strange. That is because the architecture used in microcontrollers, called Harvard architecture, utilizes two memories, one for data and one for code, and each memory of them has a separate bus. So this is different from this architecture. Now this architecture is called von Neumann, and it has the data and code on the same memory and on the same bus. So this is the difference between regular computers and microcontrollers, and I hope this removes any confusion. You can think of I/O modules as something that deals with external devices like a mouse, a keyboard, or any other external device, and on some level it is just a memory, but it deals with I/O devices. And the system bus, there is not much we can say about it here, and just think of it as something that keeps all the elements interconnected. Now we discussed the four basic elements of a regular computer. See you on the next video, where we discuss the evolution of microprocessors.